In the 1340s, the Black Death scourged across Europe, altering the history of the world along its path. Carried across trade routes from China, it infected rats and other vermin, spreading itself to humans, causing death in as little as 24 hours. After 25 million people, over a third of the population of Europe had died, the disease subsided, but remained constant for over 300 years. At the time, this disease and many others had no explanation and therefore went untreated and were able to spread. It wasn't until the 1670s that bacteria would be discovered, and it wasn't until 1928 that antibiotics would be discovered to be able to treat these diseases. So why didn't they know about bacteria? Well, because bacteria are small, 1,000 times smaller than a drop of water. So small they can't be seen unless under a microscope, and yet they had such destructive power. So what about things smaller than bacteria? Could they also have a power that we could perhaps use to combat the diseases of today? What I work with are quantum dots. They aren't living like bacteria, but they're just as powerful. Discovered in 1988, these particles are made of a special material called semiconductors that on a tiny scale have unique properties. At a millionth the size of a drop of water, 1,000 times smaller than bacteria, these particles will take in light or energy and then emit light in extremely specific colors, kind of like a tiny LED. They've also been shown to be potentially chiral, a word derived from the Greek word for hands. So meaning, just like your hands are mirror images of each other, but not the same as each other, you can have a left and right quantum dot, as you see here, much like you have a left and right hand. If this chirality is true, it opens a world of potential applications, including cloaking technology, quantum computing, and most importantly, tumor identification. This is where my research is focused. Because these structures are so small, it's hard to experimentally determine their properties. So what I do is simulate these quantum dots using supercomputers spread across the country, and my results thus far are extremely promising. My analysis of the smallest quantum dots show that they are all chiral. This would be a great discovery because cells themselves have chiral components, and recent research has shown that some of these components are unique to cancer cells. So we could fit a quantum dot to a cancer cell, much like fitting a glove on a hand. Then, because it can be lit up by imaging technology, it can be easily found anywhere in the body and potentially used by surgeons during operations to light up tumors with visible light. This quantum realm is very mysterious, and we learn more about it every day. But if you take anything away, it's that just because you can't see something doesn't mean you should ignore it. And just because something is small doesn't mean it can't lend a hand. Thank you.